You've never seen Saturn like this before. The James Webb Space Telescope picture we've all been sitting tight for has at last been delivered, and it shows beforehand obscure sides of Saturn we might have missed. Something significant in this planet's ring framework has come to light. There have long been tales that things are happening in the rings of the gas giant that will give us significant new insights into the genuine processes at work. What new secrets will the James Webb Space Telescope uncover in Saturn's rings? The James Webb Space Telescope showed us stunning pictures of the early universe that turned our whole understanding of astronomy on its head. Now the new telescope is turning its gaze to our nearby planetary system. We are seeing pictures of planets that we have never seen before. Saturn sparkles in Webb's photos as though it were actually another planet. One question in particular has long intrigued scientists. What is truly happening in Saturn's ring system? Until recently, specialists only had vague suppositions about this, and nobody had really thought to express what was truly happening there. James Webb was asked to look again, and thanks to highly advanced infrared technology and exceptional filtering, it provided remarkable insights. Never before have scientists looked so deeply into the structure of Saturn's rings and onto its surface. Thanks to this superior view, new parts of the ring structures are now becoming apparent and could resolve very old mysteries. Saturn isn't the only planet that appears in a completely new light because of Webb. The Space Telescope also examined Jupiter, Uranus, and Neptune. Would you still recognize these planets? It's not merely an aesthetic effect. Why does Webb depict the planets this way? Researchers have a theory, and the new pictures are said to provide evidence of previously unimaginable phenomena. Beneath the thick layers of dust and ice, something could be hiding that has remained unseen for a long time. Life in Saturn's rings. The rumors surrounding Saturn are not new. Designs have been theorized in Saturn's rings on several occasions, highlighting activities that go beyond our previous understanding. Saturn's rings were long seen as a single structure until pictures taken by spacecraft revealed that they are, in fact, multiple individual rings. Today we know that the rings have completely different formation histories and likely also entirely different ages. Some rings consist of dust and ice and were probably formed early in the planet's evolutionary history, while others were likely formed from accumulated bits of rock or perhaps even from debris from asteroids or shattered minor planets. The icy moon Enceladus has also played a prominent role in ring formation. The moon erupts fountains of ice and frozen water vapor up to 10 kilometers high into the surrounding region, thereby contributing significantly to one of the outer rings. These processes show researchers that Saturn's ring system is a universe in itself. The changes, the dynamic ice moon Enceladus, and the widely varying composition of the rings appear to form a dynamic and almost living system centered around the gas giant Saturn. In the new infrared images, the rings appear as bright, thick, flat bands with a frosted sheen standing out clearly against the dark planetary background. The glow is caused by the ice and rock particles reflecting a lot of infrared light in the rings. What do the brown spots on Saturn's surface reveal? Saturn, as a chocolate brown circle with a brilliantly glowing ring, looks markedly different. Infrared imaging has a special role here too. It is the only way to make processes inside the gas giant visible, and we urgently need to understand the processes within the planet. Perhaps there is evidence of a surface and an atmosphere in the depths of Saturn's environment. When the Cassini spacecraft photographed Saturn and surveyed the North Pole, it revealed something extraordinary. Hints of meteorological phenomena were visible in the depths of the storm system, which is shaped exactly like a hexagon. Some researchers said the image looked as though a blue sky was shining through the depths of Saturn. This is truly difficult to imagine, but we don't know what the gas giant is like inside. We only ever see the outer layer of gas and clouds, similar to Venus, where we only see the thick atmosphere that completely envelopes the interior. We know Venus is a rocky planet, as demonstrated by intriguing images taken by spacecraft during the 1970s. Although calculations have shown that planets like Saturn and Jupiter are likely composed only of gas and their interiors, we could be wrong, and there might be something like a solid core after all. This last image was captured following a 20-hour exposure of the gas giant. Webb then combines several raw images taken with different infrared filters into a single image. The new image of Saturn shows the planet as a dark circle in warm orange and brown hues. This picture contrasts significantly with the famous Hubble Space Telescope images, which often show Saturn with bright bands of clouds. The reason for this different appearance is that Hubble could only capture light in the visible spectrum. Thanks to the new picture, scientists now see the upper layers of Saturn's atmosphere in a completely new light and need to use these images to finally understand methane absorption in Saturn's current environment. Methane absorption causes the planet to appear dark in the image, allowing scientists to determine the exact distribution and density of methane gas in the dark areas. Two dark spots stand out particularly. The concentration of gas seems to be especially high here, which in turn gives scientists more insight into the processes in the deeper layers of the planet. Methane is the third most common gas in Saturn's atmosphere after hydrogen and helium. The atmosphere at the edge of the planet's disk glows brightly, possibly due to methane fluorescence or emissions of trihydrogen particles. The picture was taken near the end of the 7-year summer in the planet's northern hemisphere. Seasons on Saturn last so long because the planet takes around 29.5 Earth years to orbit the Sun once. This long orbital period means that each season on Saturn lasts more than 7 Earth years, resulting in extreme and persistent climatic changes on the planet. During these long summer and winter periods, temperature and weather patterns can change drastically, resulting in phenomena such as solid storms and unusual atmospheric conditions. These extreme seasons also contribute to the development and alteration of methane and aerosol structures in the atmosphere, which can now be accurately observed for the first time by telescopes like JWST. The images thus help us study Saturn's meteorological cycles and its seasonal changes in detail. The changes on the surface and in the upper layers promise new insights into the deeper layers, and here we could be in for some surprises. Webb also captures images of Saturn's moons. Who would have thought that Saturn's moons would also appear in a new light? In the new images, Webb managed to capture 3 of Saturn's 145 moons: Dione, Enceladus, and Tethys. Enceladus, in particular, is fascinating as it ejects fountains of water almost 10 kilometers high from an underground ocean into space. Phosphorus was recently discovered there, making Enceladus a promising candidate in the search for extraterrestrial life. Enceladus is a fairly small moon with a diameter of around 504 kilometers. It is much smaller than Saturn's moon Titan, which has a diameter of 5,150 kilometers, or Jupiter's moon Europa, which has a diameter of around 3,121 kilometers. Nevertheless, there are many moons around Saturn that are much smaller than Enceladus, some measuring only a few hundred meters in diameter. If there were life on Enceladus, the size of the potential habitat would be roughly equivalent to the area of the German state of Lower Saxony. Dione and Tethys are also medium-sized moons of Saturn. The former has a diameter of around 1,122 kilometers, making it slightly larger than Enceladus. The latter, on the other hand, has a diameter of around 1,066 kilometers, making it slightly smaller than Dione but larger than Enceladus. Both moons are known for their icy surfaces and interesting geological features, making them intriguing objects of study. Some of NASA's upcoming missions will travel to these promising and still largely unknown celestial bodies. Webb illuminates Uranus, Neptune, and Jupiter. It seems almost magical how different old acquaintances like Uranus, Neptune, and Jupiter appear in the images from the James Webb Space Telescope. Anyone unfamiliar with which planets are visible here would think that Webb has taken photos of a strange and wonderfully colorful alien star system. By highlighting the rings and specific gases, none of these planets look like we know them from different images. For a moment, it is almost disheartening to think that these beautifully glowing worlds do not exist somewhere in the universe. Webb has captured the planets in different light frequencies to reveal new details and secrets. The new appearance alone shows how little we really know about these planets and how much there is still to discover. The rings of Uranus and Neptune are so faint that they are barely visible with other telescopes, but here Uranus's rings shine brightly. You don't need to be an expert astronomer to understand that Webb's channels offer exceptional opportunities to examine these ring systems more closely. The highlight of this filtering isn't just the light or the unique beauty of these images. Webb can perform more precise analyses from the light beams of each individual component imaged. This telescope reads light like no other before it. Minimal radiation is enough to determine the composition of gases and the presence of specific elements. Uranus reveals not only the intriguing ring system in infrared light but also entirely new views of the atmosphere and the dynamic processes of the planet. Infrared light effectively penetrates thick atmospheres and cloud layers, revealing deeper structures for the first time. The images reveal complex atmospheric patterns that would never be visible in ordinary light. For the first time, dynamic atmospheric observations are now possible on a planet that is millions of kilometers away from us. Neptune also shows us many more details of its turbulent atmosphere in infrared light. The James Webb Space Telescope, JWST, continues to redefine our understanding of the cosmos with its unprecedented observational capabilities. Its ability to peer into the distant reaches of our solar system and beyond has provided scientists with invaluable data, sparking new questions and potential discoveries. One of the most striking features of the JWST's observations is its capacity to capture the atmospheric and surface details of planets and moons with remarkable precision. For example, the telescope's infrared capabilities allow it to detect heat signatures and chemical compositions that are otherwise invisible to visible light telescopes. This has led to groundbreaking insights into the atmospheric conditions of various celestial bodies. The detailed infrared imaging of Saturn, for instance, has not only revealed new structural details about its rings, but has also provided crucial information about the planet's atmospheric dynamics. By studying the heat emitted from Saturn's atmosphere, scientists can infer patterns of weather and climate that were previously obscured. This includes detecting temperature variations across different latitudes and altitudes, which can help scientists understand the mechanisms driving Saturn's weather systems. JWST's advanced technology also extends to its ability to analyze the chemical composition of planetary atmospheres. By studying the spectral lines of light that pass through or are emitted by a planet's atmosphere, researchers can identify the presence of various gases, such as methane, ammonia, and water vapor. This technique has proven especially useful for studying exoplanets, where direct observations are challenging. In the case of Jupiter, for example, JWST has been able to map the distribution of atmospheric compounds in unprecedented detail, offering new insights into the planet's complex weather systems and its interaction with its moons. The study of exoplanets, or planets outside our solar system, has also benefited immensely from JWST's capabilities. The telescope's ability to detect the faint light of distant planets and their atmospheres has led to the identification of new exoplanetary systems and the characterization of their atmospheres. By analyzing the light from these distant worlds, scientists can determine their composition, temperature, and even the potential presence of liquid water, one of the key ingredients for life as we know it. In addition to its planetary studies, JWST has also contributed to our understanding of the formation and evolution of stars and galaxies. The telescope's deep field observations have revealed galaxies at various stages of their development, from early, rapidly forming galaxies to mature ones. These observations provide a snapshot of the universe's history, allowing scientists to study how galaxies and their constituent stars formed and evolved over cosmic time. The study of star formation is another area where JWST excels. The telescope's ability to observe through dense clouds of gas and dust has allowed astronomers to peer into regions of space where new stars are being born. By studying these regions, scientists can gain insights into the processes that govern star formation and the conditions that lead to the birth of planetary systems. JWST's observations are also helping to answer fundamental questions about the nature of dark matter and dark energy, two of the most elusive components of the universe. While dark matter and dark energy cannot be observed directly, their effects on the observable universe can be studied through their influence on the behavior of galaxies and galaxy clusters. JWST's ability to observe distant galaxies with high precision helps researchers map the distribution of dark matter and study its effects on the structure of the universe. Another exciting aspect of JWST's mission is its potential to detect signs of life on distant exoplanets. While direct detection of extraterrestrial life remains a long-term goal, The study of exoplanet atmospheres can provide indirect evidence of biological activity. For instance, the presence of certain gases such as oxygen or methane in the right ratios could suggest biological processes. JWST's advanced spectroscopic capabilities make it a powerful tool in the search for such signs of life. The telescope's contributions are not limited to its primary mission goals. Its observations have also sparked collaborations across various scientific disciplines, from planetary science and astronomy to atmospheric science and chemistry. By providing a wealth of new data, JWST is fostering interdisciplinary research and encouraging new approaches to understanding the universe. The impact of JWST extends beyond the scientific community. Its images and discoveries captivate the public imagination, inspiring a new generation of scientists and enthusiasts. The stunning visuals of distant galaxies, planetary rings, and stellar nurseries not only showcase the beauty of the universe, but also highlight the importance of continued exploration and discovery. As JWST continues its mission, it will undoubtedly yield even more surprising and transformative discoveries. Each new observation has the potential to reshape our understanding of the cosmos and our place within it. The telescope's ability to look deeper into space and time than ever before opens up endless possibilities for future research and exploration. In summary, the James Webb Space Telescope is revolutionizing our view of the universe with its advanced observational capabilities. Its detailed imaging and spectroscopy provide new insights into planetary systems, star formation, galaxy evolution, and the search for extraterrestrial life. As it continues to explore the cosmos, JWST promises to unveil even more secrets, driving forward our quest for knowledge and deepening our appreciation of the universe's vast and wondrous complexity.